Hi, my name is Skylar, and I will be talking about what the decorator pattern is. What is the decorator pattern? The decorator pattern's intended use is to decorate or extend functionality of a certain object, statically or at runtime, independently of instances of the same class. I'll be explaining what that means with the next three items listed, which are Gang of Four design patterns, structural design patterns, and single responsibility principle. Gang of Four design patterns. The decorator pattern is one of 23 design patterns from the iconic computer science book titled Design Patterns: Elements of Reusable Object-Oriented Software, written by the Gang of Four. The Gang of Four is a nickname given to the four authors, Eric Gamma, Richard Helm, Ralph Johnson, and Juan Pasillas. The design patterns in this book are used to solve common, recurring software design problems in order to make software easier to implement, reuse, and test. The design patterns in this book are divided into three types of patterns: creational, structural, and behavioral. The decorator pattern is a structural design pattern, meaning it provides relationships between objects. In the Gang of Four book, it is defined as being concerned with how classes and objects are composed to form larger structures. Earlier, I mentioned the decorator's intended use. Another way to explain its definition is that it allows for behaviors to be added to individual objects without affecting the behavior of other objects within its class. The decorator pattern was designed specifically to allow multiple decorators to stack on top of each other, while allowing each individual decorator to add new functionality by overriding methods. The last thing I'll be talking about is single responsibility principle. The decorator pattern is often used for the single responsibility principle, which states that every module should handle only one responsibility over a single part of a software's functionality. Robert C. Martin, who was a software engineer and instructor, stated that a class should have only one reason to change. In the example below, it talks about the reasons why a report should change and why those changes should be made separately. Making sure that a class or module changes for only one reason ensures reusability of code and enforces separation of concerns.
Hi, my name is Andrew, and I'll be talking about the advantages of the decorator pattern. First, it allows a modification of objects dynamically, and this is done through composition. Second, it solves the issue of permutations when creating subclasses. Third, it's more flexible than inheritance, and you'll see an example of that later on when I compare inheritance versus a decorator pattern. And then lastly, it allows a programmer to write many simple classes. Here we have a class diagram of the decorator pattern. So starting from the top, we have the component interface, which gets inherited by the component 1 class and the decorator abstract class. Next, we have the decorator 1 and decorator 2 class, which both inherit the decorator abstract class. And these decorator classes are really the main feature of the decorator pattern. If you want to add more functionality to our project, all we need to do is add another class that inherits a decorator abstract class. Here we have a sequence diagram of the decorator pattern. So starting from the left, we can see the operation is done on decorator 1. Decorator 1 then adds a behavior. That behavior is saved and then sent to decorator 2. Decorator 2 adds another behavior that's also saved and sent to component 1. And then from there, the client can do what they need to do with component 1. Next, I'll be showing an example of only using inheritance versus using the decorator pattern. And here we'll be able to identify some of the advantages I talked about earlier. I'll be showing a solid program, but with only using inheritance, and then I'll compare it to using the decorator pattern. So starting at the top, we can see we have the solid abstract class, which gets inherited by the subclasses. As we can see, each subclass has its own get ingredients and get costs. While this may seem intuitive, this can become a problem when the cost of, let's say, lettuce goes up or changes in any way. So if the cost of lettuce changes, then each class will have to be recompiled with the updated cost of lettuce. Another problem is that if a new class will need to be made for every possible salad, and that's really not very feasible. And in the next example, I'll show you how the decorator pattern can take care of these two main issues. Next, we have the same salad example, but instead of using only inheritance, we're using the decorator pattern. So we can see that plain salad and salad with toppings both inherit the salad interface. And at the bottom, we can see bacon, chicken, and vegetables both inherit salad with toppings. And by having these three separate bacon, chicken, and vegetable classes, this can actually solve our first problem from the previous example from only using inheritance. So if the cost of bacon goes up, we only need to change the cost of bacon inside the bacon class and not touch the rest of the classes. Another problem this solves is that we can add bacon and chicken, and these will decorate the plain salad class. So we can create many salads from much fewer classes. So with these three classes, we actually create 7 different salads, which would be a plain bacon salad, a chicken salad, and a vegetable salad, or we can add multiple of them together and be the bacon and chicken salad, or the chicken and vegetable salad, or have all of them be the bacon, chicken, and vegetable salad. And this really is where the decorator name comes from. We have a plain salad class, and let's say that class doesn't have the functionality we need, then we can add on top of it without having to create more classes than we need.
Hello everyone, I'm Brandon. I'm going to be talking about the disadvantages of the decorator pattern. Decorator patterns are great. You can create multiple subclasses, they're very helpful, but in the long run, maintainability decreases. For example, I have an abstract class called a window here. And talking about your regular kind of window that you'd see on a computer, and it's got a height, a width, and a description. With that, I use the decorator pattern and I implement window. So in the bottom picture, we can see that I set the fields to be a fixed value, 100, 100, and a simple window, open and close it. Nice. Easy, right? Then we move on. Now we have a little more advanced, a resizable window. And this is a subclass of the resizable window. So it's a little bit nested. And in this one, we have it where you can enter in a number and it would be able to update the fields for the height and the width. That's what's pretty great about the decorator pattern. You could also change the description if I want to, add more methods, but for now this will do. But, what if we were to have not just these 7? 7 is just a great example, but if we had 50, for example, it would be harder to maintain. You don't know where to start, and it does not scale well. If you need to change your interface, well, now you have to change all of the 50 interfaces as, subclasses as well. Here's a little brief diagram of the classes I just made. And then lastly, a nested subclass, similar to the previous example, except this time with a nested subclass, you have multiple layers that you would have to comb through to find where things are, to find where things start, and it just becomes tedious for developers.
How's it going, everybody? My name is Juan, and today I'll be going over the demonstration for the decorated design pattern. Let's get started. Okay, so what we have here is a program that I made called the Pizza Decorator, and it's using the decorated design pattern. Essentially what it is we have this base pizza here with the ingredients cheese and tomato sauce with a total cost of $5. And what we can do with that base pizza is we can add toppings to it. And our selection of toppings includes pepperoni, sausage, mushrooms, and peppers. And underneath them you can see the cost for each topping, and that is what will be added to the total cost if we were to add it onto the pizza. So let's add my favorite topping, pepperoni, as an example, to the pizza. Right here you can see the pepperoni was added to the pizza and to the ingredients list, and the 150 was added to the total cost. So let's just keep going. Let's add sausage, mushrooms, and peppers. Now we can see the pizza is completely loaded with all the toppings, all the ingredients were added to the list, and the total cost was updated to accommodate each and every topping that was added. So the way this works, using the decorated design pattern, is every single time we add a new ingredient, let's say mushrooms, rather than creating a whole new pizza that has the mushrooms, we're just adding the mushrooms onto the already existing pizza. And this is really nice for customizing objects, as long as they're rather simple, and it just makes it so much easier to make them or decorate them to your liking. Next up, I'll go further in depth on how this works with the code and how it was designed. Okay, so what we have here is the UML diagram for the Pizza Decorator program, which we saw before. At the very top is the pizza interface, which serves as a blueprint containing every single method that will be used with every other pizza class below it that shall implement it. To the left of it, we have basic pizza class implementing the pizza interface. And what this does is it creates the base pizza, which we will use to put the toppings on top of. To the right of that, we can see the pizza with toppings abstract class, which implements the pizza interface. And what this does is it serves as the foundation for the concrete classes below it, which are responsible for putting the actual toppings on the pizza. So those classes, which we can see at the very bottom, are pizza with pepperoni, pizza with sausage, pizza with mushrooms, and pizza with peppers. Each of these classes extend the pizza with toppings class, and they are responsible for decorating the pizza with the appropriate toppings. In the top left, we can see the interface called pizza. What it does, it instantiates the methods in which we will use throughout every other pizza class which will implement it. Below it is the basic pizza class, implementing the pizza, therefore defining the methods which correspond to the base pizza. We have the get ingredients, giving us cheese and tomato sauce, and the get cost, which giving us the base price of $5. Below it is the display method, which draws the crust, the tomato sauce, and the pizza, which we see in the program. To the right of that, we can see the pizza with toppings class, which has a private pizza member variable, which is used to decorate using the concrete classes that extend it. On the left, we can see the pizza with pepperoni class, which extends the pizza with toppings class. Simply put, all this class does is it runs the super methods and then it just adds onto it what is needed for that topping. In this case, we see pepperoni being added to the already existing list of ingredients, $1.50 being added to the total cost, and then pepperonis being drawn on top of the pizza. To the right of that, we can see the method decorate pizza, which is run in the main file, and all it does is when the topping is toggled, it simply adds that topping to the pizza. Alright, that concludes our presentation on the decorated design pattern. If you have any questions, leave them in the comments below. And if you enjoyed the video, remember to like, comment, and subscribe. And as always guys, thanks for watching. Peace.